Okay, so we are on page 19 today. And we're going to talk about domain and range. Domain and range are really just another way to talk about input and output, or X and Y values. Okay, so, and that's what we see at the top of our paper here. So the domain of a function is a collection of its inputs, and those would be the X values. The range of a function is the collection of its outputs, so those would be the Y values. I like to tie this back to X and Y because no matter what our function is called, no matter what variable we're using, when I look at a coordinate plane, when I look at a graph, that horizontal axis is called X and the vertical axis is called Y. It's always the X axis and the Y axis. So it helps if we can tie it back to X and Y. I know that sometimes it can be difficult to sort of keep these straight. So for domain and range, I've got sort of a pair there, input and output, I've got a pair there, X and Y, I've got a pair there. I want you to notice that out of these pairs, domain, input, and X come first alphabetically before range, output, and Y. Does that make sense? D comes before R, I comes before O, X comes before Y. So all the ones that would come first alphabetically are X values. All the ones that would come second alphabetically are going to be Y values. Does that make sense? Okay, just a little trick to help us sort of keep these straight. So one way that we can represent a function or a relation is with an input-output map or a table. And so when I've got something like this, an input-output map or a table, and I want to talk about the domain and range, those values are just listed for me. So here's my input, that's going to be my domain. Here's my output, that's my range. So as I talk about domain for this first input-output map, my domain is just this list of values, 1, 2, 3, and 4. My range then would be the outputs that those are mapped to. So 4, 5, 4, 3, and 2. And if you listed them in a different order, that would also be fine. When I ask for the range, I'm just asking what are the possible Y values. For our second map, our domain again would be those input values. So 0, 1, 3, and 4. Our range would be our output values, 3, 1, and 2. And if you put these in order, 1, 2, 3, that would be fine as well. I'm just asking what are the output values for this relation. A table is another way that we could organize information that we get from some sort of function. So our X values would be our domain. So our domain for this table would be all of these values, 1, 2, 3, 4, 5, 6, and 7. Our range would be all of the output values or the Y values. So 1, 3, 6, 10, 15, 21, and 28. I would like you now to list the input and output values for our final table here. List the input and output values for that final table. Our domain here would be 0, 20, 40, 60, 80, 100, and 120. Our range is 14.7, 23.6, 32.5, 41.4, 50.3, 59.2, and 68.1. questions here? Any questions for me so far? Okay, so I want you to notice for our tables, that y column is labeled f of x or p of x. That makes me think that these are actually just points or a table of values from a greater function, okay, from a function. These are maybe selected values from a function. When I talk about a function or its graph, which are other ways that we could represent something that we're seeing in this table, we could represent it with a graph, we can plot these points, or have an equation or a function that describes what we're seeing. Oftentimes what we get is something that's continuous. So remember when we talked about if I should connect points on a graph or not, we were asking, are these variables continuous? And that meant, do I have just the values described by the points here, or do I get the stuff in between? And when we look at a function, we're almost always getting that stuff in between. So when we describe the domain and range for something like this, something that's continuous, we have to take a little bit different approach. If I were going to list just the values between 1 and 2 for this function right here, if I were just going to list that part of the domain, remember that because it's continuous, that means that everything in between 1 and 2 is fair game, is part of my set of values here. So that means I get 1.5. I also get 1.25 and 1.21 and 1.23 and 1.24 and 1.024 and 1.025. Where I'm going with this? I get everything, every possible decimal and fraction that I could fit in between 1 and 2 is part of the domain. So we would be here for the rest of our lives just to list the values between 1 and 2. And while that sounds like a lot of fun, I think we all have other stuff that we're going to need to do eventually. So rather than try to individually list every single value that's part of my domain, what we're going to use instead is an interval or some inequality notation to be able to describe all of those things concisely without having to list them all. So when we've got a continuous graph or a continuous function, here's what we're going to do. Remember, our domain are the x values. We're going to start with our domain. And I want to start with the lowest domain value, the lowest x value. So that means I'm looking for the point that is farthest to the left. This point right here is the farthest left point on the graph, and its x coordinate is -1. Okay. Next, I want to find the point that is farthest to the right. What's the rightmost point on the graph? That would be this guy, yeah, and its x value is 5. So that means my x values are everything from -1 to 5. And since I have points at -1 and at 5, okay, points with an x value, I should say, of -1 and 5, that means I want to include those numbers in my domain. So there are two ways that we can write this. I'm going to use interval notation. We used that yesterday with our positive and negative intervals and increasing and decreasing intervals. So one way I could write this would be to say my domain is everything from -1 to 5. I'm using brackets here, again, because I have a point at -1 with an x value of -1, and I have a point with an x value of 5. So I want to make sure those values are included in my domain, okay? The other way I could write this is with inequality notation. And you saw inequality notation on your homework last night. So the other way to represent this would be -1 is less than or equal to x is less than or equal to 5. And I'm using the or equal to's, again, because I have a point here with this x value and I have a point here with this x value. So I want to make sure they're included. Both of these representations are correct, and on a quiz or a test, I would take either because they both correctly describe the domain of this function, okay? As we're working today, I'm going to give both representations each time. You can choose to give the representation that you feel most comfortable with. So you don't need to write both each time. And on a quiz or a test or a quick check, I would not expect you to write both. You only need to give me one representation. I'm going to write both each time so that if I have some people that prefer this and some people that prefer this, everybody can see to check their work. Questions for me on the domain there? Okay, now we're going to do the same thing with the range. So remember, range is y values, and that's up and down. So this time I want to see what's the lowest point on my graph. The lowest point on my graph is right here. It has a y value of -5. So my range goes from -5 up to, now I need to find the highest point on my graph. That'd be this guy right here. And its y value is 7. So from -5 to 7 is my range. So there's interval notation. And then here is inequality notation. So -5 is less than or equal to y is less than or equal to 7. Questions for me on this one? Okay, let's take a look at our next graph. Again, we have a continuous function here. Our points are connected. And then I want you to notice for this guy, I don't have endpoints. Here we had endpoints. We had a line segment instead of a full line. Here, my graph continues, and I've just run out of room on my coordinate plane to be able to keep sketching this. So remember that this continues on both edges, okay? So when I talk about my domain, remember that's my x values. So I want to start with the point that would be farthest to the left. Now, again, remember that this continues. So this is going to keep going. If it keeps going forever, do I have a point that's farthest to the left? No. Since it's going to keep going and there is no farthest left point, then I'm going to represent the sort of left end of my domain, the lower end of my domain, as -infinity. Remember, the left side of the graph is where I have negative x values. So what I'm saying here is x is going to become smaller and smaller and smaller negative numbers forever because I never run out of graph. So the lowest I could possibly get would be -infinity. And now for my farthest to the right point, again, remember that this graph is going to keep going, right? And so it gets taller, the y values grow a lot faster than it goes over this way, but it's going to keep going forever, right? It's going to keep going, and our x's are going to keep increasing and keep increasing. Will I ever have a greatest x value? Is there ever going to be a point that's farthest? No, because again, our graph keeps going forever, okay? So since there's no point that's going to be farthest to the right on this side, that means our domain goes until +infinity. So my domain here, my acceptable x values are anything from -infinity to +infinity. That really just means x could be anything. Any positive number, any negative number, any decimal or fraction, 0, anything. And then again, if I wanted inequality notation, that would look like this. I'm using parentheses here instead of brackets and just the less than signs with no equal, because infinity is not an actual point on the graph, right? If I ask you where's infinity, you can't point to it and say, well, it's right there. Since it's not an actual point I can get to, and we know there is no lowest point and there is no greatest point, we're using parentheses there. And then our range. Now, this is the graph of an exponential function, and we'll talk about exponential functions in greater detail next semester. But the thing I want you to notice for right now is that even though our graph's going to continue forever, this is not the same as a line, right? We agree that this is not the graph of a line because we've got this sort of curve here. And on the left side of our graph, we're not extending down and to the left. We're sort of tapering, right? I sort of level out here. And so while I will keep going more and more to the left, and my x values can keep getting more and more negative, smaller and smaller, right? I can keep picking x values this way. Notice that our y value isn't changing at this point, right? Our y value has leveled off. And what is it leveled off at? Well, that's an x value. Y value. What's our y value right here? 0, yeah. So our y value is limited here. I don't get every possible y value. My range has a lower limit of 0. And we'll talk more about why these graphs are like this when we talk about exponential functions next semester. But our range has a lower limit of 0. And then what about on the right side? Do I have a highest point on my graph? No, I go up forever. So our upper limit for our range would be infinity. So here, if I wanted inequality notation, I would go from 0 is less than or equal to y. Oh, just less than, sorry, not equal, is less than infinity. Questions for me so far? Okay, we have a few more examples we're going to take a look at together. I would like you to turn to page 20 for me, please. And on page 20, we're going to look at some different representations that we have as options for ways that we could describe or represent a set of points, a function, a relation. And so today, we're not going to look at the equation-y part of the function, but we are going to look at some ordered pairs, a table of values, an input-output map, and a graph. Okay? So these are ways that we can describe just about anything that we're going to encounter in Algebra 1. And then a little bit later on, we'll add in that function description for things that are functions. So we're starting with ordered pairs. Remember that these represent points on the graph. And so we'll get to the graph in just a minute. But remember that I could also organize ordered pairs into a table. I've got an X value and a Y value. So I can organize that into a table. So 4, 6, 4 is the X value, 6 is the Y value. I've also got 5, 6, 3, 9, and 4, -1. I could also describe this with an input-output map. So I'm going to list my input values in this first circle. So that would be 4, 5, 3, and then I've got 4 again, but I already have that written here, so I don't need to write it again. And then I'm going to put my output values in my second circle. 6, again, it's listed twice in here. I don't need to write it twice. 9 and -1. And then the last thing I need to do is draw arrows from the input to its output. So 4 has an output of 6, 5 has an output of 6, 3 has an output of 9, and 4 has an output of -1. There's my input-output map. And then finally, I'm going to go ahead and plot the points that I have. So I can get my points from these ordered pairs that I see here, or remember these sort of matching X and Y values in the table also represent points. So my first point is 4, 6, 4, 6, 5, 6, 3, 9, and 4, -1. And then finally, we're going to talk about the domain and range for this. So remember, domain are those input or those X values. Range are the output or the Y values. So our input values, our domain would be 4, 5, and 3. I don't need to list the 4 again. I've already got it here. And then our range values would be 6, 9, and -1. Questions for me on number 1? Okay, we're going to take a look at one more example together today. Number 2, towards the bottom of page 20. This time, they give us a graph. And then because these points are connected, that means we're continuous here. Just to sort of help us out a little bit and give us some guidance. For the table, they've selected some X values so that we're not listing every single possible X value. Because we talked about before, that would take us literally forever. So as I take a look at my graph, I'm going to pick out the Y values to finish my table. So when X is -3, 1, 2, 3, that's this point right here. My Y coordinate is 5. When X is 0, my Y coordinate is 2. When X is 2, my Y coordinate is 0. And when X is 4, my Y coordinate is -2. I would like you now to fill in the ordered pairs. Tell me a couple of, it looks like we have space for 4 points. Tell me 4 points that are on this graph, and then give me that input-output map. Fill in your ordered pairs and your input-output map. Okay. Your ordered pair shouldn't have been too bad. Just make sure in your input-output mapping that you don't forget to draw your arrows between your input and your output. And now let's talk domain and range. So since I have a continuous graph here, we're not just going to list the X values that we've selected to write a couple of ordered pairs or to do a table. Okay, we need to describe all of them. So again, we're going to look at what's our smallest X value. That means the point the farthest to the left. So the leftmost point would be this guy, and its X value is -3. So my domain starts at -3. Again, I'm using a bracket because I have an endpoint here. And then I need my rightmost point. That would be this guy. Its X component, its X value is 4. So from -3 to 4. If I want the inequality notation, it would look like this. And then for my range, I'm looking for those Y values. So I need to start with the lowest point on the graph. That would be this guy. And its Y value is -2. So my range starts at -2. And then I need the highest point on the graph. That would be this guy, and its Y value is 5. So from -2 to 5. And again, if you want the inequality notation, that looks like this. Questions for me for today? Okay, for the rest of our class time, you have an assignment on Khan Academy over domain and range from a graph. So it's going to be stuff like this and stuff like what we looked at the bottom of page 19. So identifying your domain and range from a graph. Okay. Just a reminder on those Khan Academy assignments, as long as we've got time, you're welcome to retry those assignments if you're unhappy with your score. So your domain and range Khan is due at the end of class today, but you can retry it during class as many times as you'd like. If you are happy with your domain and range score on Khan Academy, then you can also use any remaining class time we have today to go back and retry any of the cons that we had for homework last night. So we have about 20 minutes left. That should be plenty of time to be able to retry those assignments if you need to. And again, your domain and range assignment is due at the end of the class period.